Hello, everyone. Welcome back to another episode of Tantra's Mantra, where we go behind and beyond the tech news headlines. I'm your host, Prakash Sangam, founder and principal at Tantra Analyst. Today, we'll be looking at an exciting topic which has been getting increasingly more interest from the tech industry. If successful, this technology has the potential to fundamentally disrupt the entire silicon industry, that's chip industry. We are talking about RISC-V. RISC-V is an open source instruction set architecture (ISA) for processors. It is relatively new. Was developed at UC Berkeley in 2010 or so, only around 12, 13 years old. So, being a new entrant, till recently, it was not considered a serious contender against giants like Intel's x86 and ARM architectures, but obviously that has changed because of few market developments. First, because of some of the uncertainties around ARM licensing, specifically Nvidia's unsuccessful attempt to acquire ARM, and followed that by licensing dispute between ARM and Qualcomm. It's been in the news for more than a year now. And also, there is this acute need for high performance, energy efficient processors in the market, especially with AI going all out. All of this has made industry take a serious look at RISC-V. At the same time, RISC-V ecosystem is making considerable headways in developing technologies and expanding the ecosystem. There are a lot of big players interested in this architecture, but there are still a lot of questions on its roadmap, growth, and its ability to be a formidable challenger against the well established incumbents, x86 and ARM, that is. So, to discuss all these questions, we have the most suitable person with us today, and that is Callista Redmond, who is the CEO of RISC-V International, a non-profit industry group that oversees the development, standardization, and the promotion of RISC-V. Callista, welcome to Tantra's Mantra.
Thank you so much for your warm welcome. We're excited to share in our journey together regarding RISC-V and help the community, kind of get on board.
Very well. So again, thank you for coming over. Many people know about RISC-V, and especially recently. Not much is known about its origin and its journey, or at least well known yet in the industry. So, could you briefly explain that to us? You know how it started with RISC-V Foundation, a transition to RISC-V International, and so on, and also your association with the organization.
Absolutely. So, it's exciting because we're not talking about anything brand new here. The RISC architecture itself is based on ideas that go back more than 40 years to the 80s, 1980s,
Mm-hmm.
which kind of was initiated by many of the founders of RISC-V, Dave Patterson and Hennessy, and that work then went into production. It's the basis of many modern computing systems today. The initial work on RISC-V, or the fifth version of the RISC architecture, was initiated back in 2010 as part of a lab at UC Berkeley. And that lab was actually funded by industry.
Mm-hmm.
That included Intel and Microsoft, over a period of years. And
Mm-hmm.
the outcome of that is that RISC-V was released to the open community back in 2015.
Mm-hmm.
So those are some things that sort of give us longevity, but also building from a well-established foundation.
And you've been associated with RISC-V for a long time now, or?
I personally joined RISC-V back in the winter of 2019, so I'm coming up on
Mm-hmm.
5 years with the organization.
Mm-hmm.
And, prior to that, I was over at IBM for about 12 and a half years. And previous to that was, an entrepreneur with 4 successful startups.
Mm-hmm.
In my time at IBM, I helped and was part of founding or running of 3 different open hardware movements
Mm-hmm.
in networking, as well as the power architecture, and then also around mainframes. So I have a long history with open collaboration for the hardware part of our industry, and it was really an honor to be called to take the helm and the stewardship of RISC-V through RISC-V International.
Indeed, it's all the right background to take RISC-V to the next level. So, you recently concluded a major summit in the Bay Area, your America's Summit. Could you talk about that and what were some of the takeaways from the event?
So, the RISC-V Summit North America was our third major summit this year. We've grown, and
Hmm.
this was the first year that we had a major summit in Europe as well as China, and then also North America.
Hmm.
So it really, starts to showcase our global adoption and momentum that we're seeing, which were definitely highlights, and you could see and feel that engagement and energy across more than 1,000 folks that joined us at RISC-V Summit North America. In fact, we were up 40% year over year in the number of registrations we saw, and nearly everyone actually attended as well. So it's one thing to talk registrations and then you count, well, how many people actually picked up their badges? And wow, the energy and the excitement, the collaboration, the networking, the innovations, the showcase of hardware in our developer zone, everything really captured the spirit, attention, and momentum that we're feeling and seeing around the world. So, it was a great event to talk not only about the progress that we've made, I think at an accelerated momentum than even prior forecasts had shown for
Hmm.
RISC-V adoption. And that's something that was you could really see. It's not just talk about the future, but the future is here.
Hmm.
And those are some of the key milestones that we've been looking for and had been working hard on over the last year.
Yeah, indeed. So there is a lot of tractions for sure, but Risk 5 is still at a very early stage, right? I mean, if you look at the use cases and the implementation, it's primarily in smaller, simpler processors, maybe microcontrollers for IoT, in wearables, etc., or it could be embedded inside SoCs of for doing specific tasks and so on. So I mean, what is the roadmap for the project? When do you see RISC-V to be used for beefy processors, be it in smartphones, running the main SoCs, in big computers, and so on?
So it's interesting. I think a lot of the work that has been underway, really you could see at the summit this year. So it takes a few years for hardware to get from idea to tape out and implementation.
Uh huh.
And that's something that is, a hardware special thing. It's not like software where you can suddenly invent it, do a few pull requests and away we go. Hardware takes time, and so does the cultivation of open standards.
Mm-hmm.
So first, just as as some background, RISC-V is a global standard. We're often compared with open source. Some of the similarities are that it is free and available for anyone to use and implement,
Mm-hmm.
and we have a lot of contribution from the community that makes those standards possible,
Mm-hmm.
and a democratic nature whereby we jointly agree on what those specifications are going to be and ratify them through a lengthy governance process. And we've accomplished many of those this year. In fact, we're on course to complete 18 this year alone.
Mm-hmm.
But as an open global standard, we don't apply patch updates like you do in software. We set the standard for the durable and foreseeable
Mm-hmm.
future of compute. And that's something, to get back to your question, the embedded space took off first. And that's a space that you've been seeing a lot of traction in, a lot of announcements and momentum through events like Embedded World. And that traction and momentum has been extremely strong over many years.
Uh-huh.
And you're now seeing a lot of that start to move up the compute, complexity, right? So into higher performance workloads.
Uh-huh.
Over the last few years, you've seen announcements of companies like Esperanto or TensTorrent or Ventana
Yep.
talking about data center, talking about those high performance workloads. Ventana is one who made an announcement about their VRON 2 at the summit that is even more,
Mm-hmm.
not just parity, but parity plus to other architectures. You heard from Meta, who has brought RISC-V into their data centers for AI and acceleration. You heard more from Qualcomm shipping billions of cores every year
Mm-hmm.
as they, kind of, tag together with the folks over at Android.
Yep.
And Android has made significant announcements as well. So bringing it into handsets. In fact, it was a big moment for us at the summit when you heard a phone call being made from an Android smartphone on RISC-V, and that's something that we've been looking forward to for some time, and something that we see becoming real.
Yeah, indeed.
In fact, I came home from our RISC-V summit in China with the world's first RISC-V laptop. So these are, we've moved well beyond embedded, and these are now implementations that are coming to market across that compute spectrum. Just this week, in fact, at Supercompute, there was an entire day dedicated to RISC-V and had many sessions, including a sort of an innovations and speed round that you got to see a lot of those new high performance RISC-V workloads coming to bear.
Yeah, that's pretty impressive. And also, I think it's the right before the summit, Google came out and announced that they are moving Android and RISC-V from just patch to what they call matured status or something like that. And also, Google and Qualcomm talked about RISC-V support for Wear OS. So, could you talk about those as well? What those mean to the ecosystem?
Yeah, so oftentimes, software and applications out in the ecosystem want to see the base operating system support before running on that architecture, and that's been true whether it's x86, ARM, RISC-V, Power, Z. All of the architectures have many different operating systems that run on multiple architectures. And by the way, that's not just for technical chops, that's because it's in the business interest.
Yeah,
So if you're sitting over in one of those organizations, Android or Red Hat or SUSE, you want to be able to run on all the major architectures. And this signals to the market that RISC-V has arrived
yeah,
and that it's time to get your application running on RISC-V, at parity or better, fine-tuned to the architecture on RISC-V. And so this is unleashing a lot of more uptake across the ecosystem. In fact, we've had to pivot to a more dynamically created, logo chart for our ecosystem. So hundreds of workloads have been coming on board. We have all the major libraries on, tools and design resources for
yeah,
hardware design, as well as accelerating developer on-ramps. These are things that are in our focus as we accelerate that ecosystem.
yeah,
Honestly, I look at ecosystem. It's interesting. There are folks out there who think it may take us decades to catch up. But since we're the collective investment of stakeholders around the world, and that is, something that we see multiple parties investing in at once, those workloads are coming online rapidly. And we expect that in the next year or two, you're going to see all the major workloads are running on RISC-V. That, runs in parallel to the hardware we're seeing.
indeed. So I think one of the challenges that I see is huge amount of legacy software built on x86 and ARM. Porting that over to RISC-V is one of the challenges. I know that the more porting happens, the faster the ecosystem will grow. Is RISC-V International doing anything specific to that ecosystem?
So RISC-V is doing a lot for the ecosystem. We have launched developer labs where developers can get support
Hmm.
for bringing their workloads onto RISC-V. That includes, both real hardware as well as virtualized environments.
Hmm.
At our RISC-V summit, we had the developer zone where you had more than 40 different developer boards on hand and ready in production. And those developer boards are very instrumental as well. Organizations like RISE have come up over the last year to help with some of the tooling around that.
Yeah,
And we're investing as RISC-V International in accelerating that developer on-ramp with work that we're investing in for the developer experience.
yeah.
If you look at, developer.nameyourfavoritearchitecture.com, that's something that RISC-V will have in the coming year.
Very well. And I know you talked about running multiple workloads on RISC-V. I mean, there is a lot of AI buzz around, and it's at a pretty nascent stage right now, in my view. and that kind of gives a good opportunity for RISC-V to exploit, right? So are you doing anything specific to harness that opportunity and make RISC-V excel there?
AI is absolutely the buzzword du jour, right? I mean, everybody wants to infuse some level of AI along with acceleration.
Of course, yeah.
New workloads, these ways to augment and accelerate and get more out of the compute power is something that there isn't really a existing monopoly on by any other architecture. So
Hmm.
going after new workloads is something that has been a huge business and technical driver for startups, for mid-size, for multinationals, for applications that are running on other architectures to focus their energy over to RISC-V. And you look across some of the analyst reports, some of the reports I shared at the summit
Hmm.
really show that RISC-V is being taken seriously in AI, from consumer AI, where we're predicted to capture 36% of the market by 2030, or automotive AI acceleration, where RISC-V will capture 27% of the market. That's a lot. That's an incredible level of the market. In fact, in automotive, it's been said overall RISC-V is going to come in at 10%. And so, figures like this show that there's a lot of work going on within organizations already. To hit those dates and those time frames, that's work that's already underway. You hear from organizations like Meta and Alibaba who are actively bringing RISC-V for AI acceleration specifically into their data centers.
Uh-huh.
And that brings you into, sort of that next realm of establishing RISC-V as a very formidable architecture to handle those workloads. And
Uh-huh.
the biggest piece of this is that design flexibility. Design flexibility translates to both technical innovation
Hmm.
as well as business opportunity. When you have that level of freedom, you're able to differentiate and compete much more effectively within your market space.
Yeah, I agree. So with the flexibility and the modular design, when you're taking these two different kinds of workloads, it makes it much easier than a rigid one like x86 or ARM, to that extent that you adopt that architecture specifically to those, especially new markets. And AI and automotive, they're fairly new markets. They're pretty large and starting off now. So getting in now from RISC-V makes a lot of sense, right? Then you can grow with the market rather than competing very hard with existing players, which have a huge install base, right?
Yeah, and I might even add that once you start to gain experience and expertise on RISC-V,
Mm-hmm.
the potential to transition future generations of existing workloads from a proprietary architecture over to RISC-V is a much easier transition.
Yeah, true. I agree. So, coming to the licensing aspects, as I mentioned in my monologue, there was huge interest in RISC-V suddenly because of, at least from a public point of view, and media and other point of views, after the recent developments in terms of licensing litigation and so on. Did you see that as well? Of course, the work was going on, but there was uptick in interest after those uncertainties in the market.
So you've touched on a few different things. Let's start with licensing. So RISC-V is freely available as a global open standard to anyone, and that means
Uh-huh.
that anyone can take it and run with it. They
Uh-huh.
most likely are going to run with it in a way that's consistent with the extensions and other software and things to remain in lockstep with the latest developments.
Uh-huh.
Outside of that, they would be kind of left holding on to and developing an ecosystem singularly.
Mm-hmm.
But the benefit of working in an open global standard, much like you see in Ethernet, USB, HTTP,
Mm-hmm.
standards that have
Mm-hmm.
transcended the scope of geopolitics to become innovation engines. That spurs opportunity for anyone to, sort of take that global standard and develop best in class, components that are interoperable with the rest of the world.
Hmm.
And the rest of the world is very important. When you glue into a global standard, that means that you have expanded your opportunity to find development partners,
Hmm.
supply chain, and market opportunity. So both what comes into the product as well as where you can take it to market.
Hmm.
And if you think about the number of things that we plug into USB, the secret sauce is not the USB, it's whatever you decided to plug into it.
Uh-huh.
The secret sauce on HTTP for web protocols isn't that you're using HTTP. It's the content and the capabilities of the website that you put in that browser window.
Yeah.
So, RISC-V is really kind of come in at a time where there isn't an open global standard for instruction set architectures. But as I said earlier in my remarks, this isn't brand new. The RISC architecture has been around since the 80s.
Hmm.
What it is establishing a global standard that anyone can leverage. And then from there, innovate and differentiate on that global standard. So I think that's an important, area for everyone to sort of understand, prior to thinking about parameters of geopolitics or commercial pressures or things of that nature,
Hmm.
which really are outside of what global standards are really about.
Okay. And in terms of being open source, it has done wonders for Android, but it also has challenges as well, right? In terms of fragmentation, forking it, and so on. How are you looking to manage it from a RISC-V point of view? Just put in some guardrails that the ecosystem can't veer off and so on, or?
So RISC-V is not open source, it's an open standard. And to that end, it's not something that is patched or updated later. Once we ratify an open standard, that's the standard for the test of time.
Mm-hmm.
Just as you would not want to take your USB standard and fork it off into the wilds by yourself because you'd then, be kind of constrained to the ecosystem that goes with you.
Mm-hmm.
RISC-V is not, something where folks would want to take that approach either. When you think about, why, ascribing to a global standard is important, ecosystem comes hand in hand with that.
Mm-hmm.
Just as much as you think about the investment needed to support the ecosystem that glues into your standard, that is sort of a positive force that prevents anyone from any country, company, anyone from wanting to take a forked path on that. They want to continue to engage globally, whether you're building products and have development partnerships or going to market and want to have that market opportunity. You want to continue to ascribe to that global standard. When you think about an example like Ethernet, once upon a time, there were many proprietary ways of networking your data center. And those proprietary methods of networking your data center also made it that you had to take that same proprietary approach on what goes into your data
Mm-hmm.
center. So the servers and other storage and other units that plugged in. That proprietary path is now obsolete. Ethernet came in, and now you have the opportunity to really bring any server in that ascribes to that global standard. It's very similar here. By taking a forked path, you cut yourself off from opportunity, and that is, usually not the business decision that is going to move forward.
Yeah, true. I mean, it's true in Ethernet's case, but at the same time, if you look at Android, I mean, large companies like Amazon and others, they try to fork and then create their own ecosystem and so on. So we'll see. I mean, it depends on how big companies want to do it, whether they want to control it to their ecosystem or just rely on the global ecosystem and take advantage of that, right? So, yeah, in terms of licensing, I mean, it is an open standard and it is free, but I'm assuming there are a lot of people who in the ecosystem who take it, build their own IP on the top of it for differentiation and what have you, and they can license it for price or free to the ecosystem, right? And they own the IP that they develop on the top of RISC-V. They're not required to give that all back to RISC-V, correct?
Yes, I know that there is confusion out there in the market on how does all that, work. Is RISC-V free? And I always, want to be sure and clarify.
Uh huh.
So leveraging an open global standard is always free.
Yeah.
What you put on top of that for your differentiation,
Mm-hmm.
that specialized IP, the areas that you create to glue onto that global standard, those can be proprietary or open.
Uh huh.
So the final implementation may often contain areas that you license IP from others. RISC-V International does not have a licensing fee structure
Mm-hmm.
across any of the base standards, the ISO or the specifications and extensions that you're free to use to glue on top of that. But there are many folks, many design houses, many IP design houses, in fact, more now on RISC-V than any other architecture in history. They do have specialized IP that is, fine-tuned for that custom processing.
Uh huh.
So when you think about RISC-V, think of it not as holistically free when you start to bring in that differentiated IP, but it's freedom of design.
Uh huh.
And freedom of design is what really enables and accelerates the business value of working on RISC-V.
Indeed. And if you have a commercial licensing model compared to a open standard open sourced one, there is revenue generated with the licensing that feeds the innovation engine, right? But in open source, that's kind of absent, and you're relying on the ecosystem partners to develop it as a community, and so on. So how do you see that affecting sustaining this development and this pace of development and so on? Mean, it might start good, but when the big companies come in, one, they want to, customize it to their liking, to their ecosystem, and second, they want to develop on their own, and what they develop on their own want to keep it for their own ecosystem, not plowing it back to the ecosystem as such.
So as we look at what we cultivate and develop as a community, and there are about 75 different technical work groups that are going today,
Mm-hmm.
ranging from security to, vector extensions and things like that.
Mm-hmm.
We work on the things that we want everyone to have access to.
Mm-hmm.
We don't focus on that proprietary value. That's up to implementers and customers and end users that really are looking for that piece of differentiation.
Mm-hmm.
We work on what are the common building blocks that folks would like to have to move towards their implementation.
Mm-hmm.
And that's like the beauty of RISC-V. It's very modular.
Mm-hmm.
So you have your base ISA, and then you have a menu of extensions that you can add on to that, depending on the workload and the design constraints that you're wishing to meet, or the design goals, right?
Uh-huh.
Maybe it's performance or power or space constraints.
Uh-huh.
So by leveraging a open modular standard, you can get all of those base building blocks.
Mm-hmm.
And then we have reserved encoding space to add in your own differentiation or to, leverage in a way that benefits your final product. And so, RISC-V really does, work in collaboration with our community. We're very community driven,
Mm-hmm.
and it's the contributions to those base building blocks that individual companies and other stakeholders have deep vested interest in.
Mm-hmm.
So they, will get together, decide on, the specifics of those base building blocks, and think of that as sort of the commoditized layer of design. Those are, sort of like we all need
Mm-hmm.
cement and, wood to build our house, but, how you decorate that house yourself and bring it to market is really up to you.
Mm-hmm.
So we together share in the cultivation and development and ratification of that.
Mm-hmm.
And when this is of deep strategic interest to you as a company, whether you're a startup and your only architecture is RISC-V, or you're a multinational and you're investing deeply in RISC-V across multiple business units for various implementations, you want to be engaged in that community.
Mm-hmm.
And that community does more than just, the specifications and extensions, but it also works on tooling and resources to accelerate the on ramp for the developer community.
Mm-hmm.
And so engaging deeply in that, regardless of your perspective, is essential. And we have deep engagement from Red Hat, SUSE, and Canonical, and Android, and those next layers of the ecosystem as well.
Mm-hmm.
Because at the end of the day, they want to run best on RISC-V just as they would on any other architecture. But by being in RISC-V, they're able to accelerate their own optimizations.
And this collaborative approach hasn't been a block in terms of fast improvement in terms of performance and the architecture itself. If it is open source and community managed and led, you need consensus and so on, right? I mean, having a modular design really helps so that you can focus on the right things. But you haven't seen any impediment to fast paced development that is needed in tech today. If you look at Android, although it is open sourced, I mean, there is one big company as a force behind it. In RISC-V, it is basically collective effort of all the companies involved, right? There is no one dominant player pushing forward. So how that dynamics helping or hurting you in any way?
I think we're actually moving faster than what you've seen on any other architecture.
Uh-huh.
So, I mean, I think x86 was, the earliest out the gate in terms of driving their agenda, right? And their agenda was sort of the driver that everyone had to wait for, look for,
Yeah.
and ascribe to, whether it fit for their implementation or not.
Mm-hmm.
And then, ARM came in and they did it a little bit faster, but for many workloads, it was porting from x86 over to ARM, and that was from a CISC architecture to a RISC architecture.
Yeah.
Now we're moving even faster than they did because, first and foremost, your destiny here is not driven by one proprietary interest.
Mm-hmm.
Your own interests are self-driven as well as within the collective interests of your peers and other colleagues who also want to see those base building blocks
Mm-hmm.
with full transparency
Mm-hmm.
and ability to influence those decisions. No company had that level of influence in prior architectures or in other architectures that are out there.
Mm-hmm.
And this, spans from applications and libraries into infrastructure, runtimes, operating systems, hypervisors, boot code.
Mm-hmm.
There are many stakeholders that are engaged here. That collective drive is much stronger and self-driven
Mm-hmm.
than what you would find if you ascribe to the proprietary roadmap
Mm-hmm.
of another architecture. So we're actually moving faster and with greater consensus in the community and running multiple of these streams in parallel.
Mm-hmm.
So, we're not gating any of our implementers by the next release. And in that, they're able to start their development sooner and get to market faster. And that's what we're seeing as we, go around the world to all of these different summits and,
Mm-hmm.
more than 90 other events throughout the last year, as we see those implementations coming to market.
Okay. And there is more, R&D, and it's more interest because you have multiple companies, multiple people involved, right? Not just one dominant force. So you're not beholden to one company and its limitations. Yeah, correct. Okay.
It's an absolute multiplier effect.
Cool. So my last question. So where do you see RISC-V in next 5 years?
I think you're going to quickly see RISC-V surpassing other architectures in new workloads. You're going to see the beginnings of RISC-V taking over existing workloads, from embedded to data center, and all things in between. You're going to see a explosion of ecosystem applications, libraries, tools, and other things coming on board,
Uh-huh.
bringing us to parity, or what I like to think of as parity plus across all the major workloads.
Uh-huh.
You're going to continue to see RISC-V as the architecture of choice for new and emerging workloads.
Uh-huh.
And within the next 10 years, you're going to see RISC-V in everything.
Uh-huh.
In fact, I spoke with one analyst who had previously told me a couple of years ago that he's seeing RISC-V in more than 25% of designs.
Uh-huh.
I caught up with that same analyst this last summer, and I said, "Well, what would you say today?"
Mm-hmm.
He looked at me for a minute. He's like, "It's actually hard to find any designs that don't include RISC-V."
Mm-hmm.
And those are new design starts. So as those start to come through the fabs, that's our new reality. RISC-V is everywhere, and RISC-V is in everything.
All right, excellent, Calista. Thank you very much for coming over to the show and providing your insights. It indeed is exciting to see how quickly the RISC-V technology and the ecosystem is evolving and expanding. I'll be closely monitoring the developments, and I know will definitely invite you to come on the show again as we move forward sometime in the future. Hope we'll be open to it.
Prakash, it's been an absolute delight to catch up with you. I invite any of your listeners to join us over at riscv.org to kind of stay up to date on the latest and engage with the community.
Indeed, thank you very much. So, folks, that's all for now. Hope you found this discussion informative and useful. If so, please hit like and subscribe to the podcast on whatever platform you are listening this on. Don't forget to check out our previous episodes as well. I'll be back very soon with another episode, putting light on another exciting tech subject. Bye bye for now.